Welcome you all. I am Dr.M.Lena, Assistant Professor, Department of Zoology, Sri Sharda College for Women, Salem. I am going to discuss about micrometry is the art which we have some measurement of dimension of object being observed under microscope. For example, you have some microorganism and you need to estimate the length or width of a particular organism. You can go for this particular micrometry. This method employs special types of measuring devices. Once we can observe an object under microscope of 5x objective and the 10x eyepiece, we say that image that are able to perceive is 5 into 10, that is 50 times of. For this, we have two different types of micrometer. One is stage micrometer and another one is ocular micrometer. It is clear from the name, this particular stage micrometry should be kept in the stage position of the microscope where we will keep slide and all. This micrometer is of slide shape. Similar to slide, this micrometry will be there and it is having a graduated scale in its center. So the scale measures of 1 mm and has a least count of 0.01 mm. The 1 mm region is divided into 100 division as it is equal to 1000 mu. So one division of stage micrometry is equivalent to. So this picture shows the stage micrometer. So we can see this one as 1 mm is divided into 100 subdivisions. This stage need to kept in the stage position of the microscope. So it look like a slide. With the slide we will have some graduated scale. This is the graduated scale which is present in the stage micrometer. Coming to ocular micrometer, this micrometer is used inside the eyepiece. You need to open up the eyepiece, unscrew it, and you need to insert the ocular meter inside that one, and the micrometer will be like this. So it will be having some calibration value. Here also you can observe 10 mm is divided into 100 subdivisions. So this is the ocular micrometer which is present inside your eyepiece. So one ocular division is equal to number of stage micrometer division divided by number of ocular micrometer division. So first you need to superimpose the stage micrometer and the ocular micrometer, set up to 0 position, and you need to read out the superimposing position in both the stage and ocular micrometer. With that calculation, we are going to calibrate the reading. Graduations on the ocular micrometer are calibrated against the standard graduation on the stage micrometer. For this, calibration is required because the distance between ocular graduation varies depending upon the object being used, which determine the size of the field. So, next step is our calibration. Now we are going to see about the calibration, how we are going to take average calibration value and how we are going to measure the length of the organism.
Discussed already, one ocular 10 mm is divided into 100 subdivision and one stage 1 mm is divided into 100 subdivision. So one division of stage is equal to 10 micron. For the procedure of doing micrometry, first you need to insert the ocular micrometry inside the eyepiece of your microscope. Inside the eyepiece you need to put the ocular micrometry, and in the stage of the microscope you need to keep the stage micrometry. So after keeping, you need to superimpose both the images. This is the superimposed image. So this is the stage micrometry, this is the ocular micrometry. So stage micrometry and ocular micrometry need to be coincide. We need to estimate the number of coinciding line for our calculation. For example, see, this is the stage micrometry. Now we are going to count 1, 2, 3, 4, 5, 6, 7. So the seventh line, it is indicated in the white line in the image. So seventh line of stage is superimposed with the 1, 2, 3, 4, fifth line of ocular 10x, number of stage division 7, and number of ocular division 5. So the value 1 ocular division is equal to 1 stage division divided by ocular division into 10 mu. So 7 divided by 5 into 10. Similarly, coming to the next reading, count the next value. Next superimposing point is, this is the 20th line. So 21 and 15 is balancing. So 21 and 15, 21 by 15 into 10 is equal to 14. Here also 14. Similarly, you need to calculate at least 5 values. So I am adding 28, superimposing with the 20th ocular division. Again 35 in stage and 25. So it is indicated in the white line, and 25 of the ocular. 45 of stage is coinciding with the 32nd of the stage ocular. So you can see here clearly the number of stage and ocular superimposing, merging at a single point. So wherever it is merging, all the points you need to calculate, all the points in stage individually and all the points in ocular individually. So next, coming to the calculation part, 1 ocular division is equal to stage division by ocular division. So you need to calculate by using the formula 35 into 20 by divided by 25 into 10. Similarly 45 divided by 32 into 10. So you get 14 as a value. Now with all the 5 readings, you need to calculate the average. So 14 into 5 divided by 5. So again we will get 14 as the final value. So number of calibration value in your ocular is 14. So keep this 14 as standard. This 14 is the calibration value of the ocular and stage, which is calculated under the formula of superimposing. So after superimposing, you estimated the value of calibration as 14. Now you can remove the stage micrometry and we can keep only ocular micrometry for your calculation. So already we have the value as 14. Now we removed the stage micrometry, we have only ocular. Now we are going to estimate the length and width of a particular animal. For example, we are having some Euglena or something you are having in hand. So the measurement, this is the length and this is the width. So measurement of how many ocular is calculated with the total length of animal and how many ocular division is coming for the total width of the animal. For example, if it is coming like 0.2, so the length of Euglena or other organism, length of some organism is estimated and that value is taken and it is multiplied into your calibration value. Why? Because we are already derived the stage and ocular reading. We are removing the stage micrometer and we are imposing that one. So we are adding 0.2 into 14. So this is the answer for the entire length of the organism. Similarly, for 0.4, for example, width of organism is 0.4, you need to multiply with the calibration value. So for micrometry, first you need to see the superimposing point, you need to superimpose stage and ocular micrometer and you need to calibrate the value, then remove the stage micrometer, keep the ocular micrometer alone, and with the help of, suppose you need to measure some length and width of organism, take the organism and keep in the stage of your microscope. So you need to multiply with the calibration value along with the number of ocular division for the length of a particular organism. If it is a Euglena like that. Okay, so like this you need to calculate the value and length and width of the organism with the help of micrometry. Thank you.